to look at the data so you all can't see it. So as an instructor, I don't give away everything. Okay, so there you see the 111. And what was important here is that it should be in your chat. And what's important here is that we have a pattern that we see in the shapes, but we don't see it. Oh, wait, I'm getting all sorts of information here. What's going on? What am I getting here? Is everything fine now, you guys?
Working on it.
Do you see the 111?
Sorry, it's on our end.
Okay. Okay. So there's the 111, and we're looking just at base 8 and base 9. We can look down. I'll show you. There's base 6. You can see it there. There's base 7. You should be able to see it there. Base 8. And there's base 9. So I'm going to go back to the double view of where you see 8 and 9. And we see that this pattern, it's a meta pattern, shows up. It was in discovering this meta pattern that we made a profound advancement in mathematics. And the reason is the shapes, when we moved to shape value rather than place value, they describe the algebraic relationship. We have 1 square. If I look at the 8s, I have 1 8 square, I have 1 8 seg, and I have 1 left over. And the 9, I have that same pattern, 1 9 squared, 1 9 seg, and 1 left over. And the general pattern is 1 x squared plus 1x plus 1 left over. Let me put in a different one, and we'll see if we can't. If you look at the remote device in the middle, you can see what I'm doing. I'm clearing it all off. And now I'm going to put in 5, 2, 3, and 4. Now I'm going to send it to the base sheets. And all the patterns now show up. And now we see the general equation would be 5x cubed, because that shows up in every base, in base 7, base 8, base 9. So it's 5x cubed plus 2x squares plus 3x's plus 4. Is everybody seeing this? Just type a Y, please. Just let me know if you're seeing this. See the 5 cubes, the 2 squares, the 3 ones, the 3 segs, and then the 4 left over.
Yeah, I'll write it out.
And I'm sorry, we just realized that we could have had the equation automatically print on the screen for you, but we didn't have enough time to program that. This is the first time we've ever really tried to present this lab where you see these shapes in this format and to control your camera so we could show you what we're doing. And with a little bit of color, we can actually show the negatives. So I'm going to show you a negative one. And here is a new equation. Now the magenta are negative. They're the opposite of green. And what happens is when you put the green and the magenta together, they cancel out. And that's because in computer technology, green and magenta make white. And so that's what we're talking about. So here's the equation. 1x cubed minus 2 squares. You can see the squares, can't you? Minus the 2x squared plus the 3x minus 7, not underscore 7, minus 7. And we find that, or we believe that if students of all ages who never got algebra can understand that it's in the numbers, it's built into your brain that you can see this. We're not trying to teach you a process right now. We're just trying to tell you what your eyes are seeing. Once your eyes see it, you'll never forget it. You can ask Rosalind. She could probably do all of these because it's built in. It's like learning the color blue. Once you know what color blue is, you don't forget what blue is. So there's no process here. That way, when we get into processes like solving equations by elimination or something, and this is only made possible because of Second Life, and we believe we'll be able to do instructions like this. Would somebody like to try? I'm just going to assume you want to try your own. And so I'm not going to do it on the sheet where you can see the answer. I'm going to a controller that's on my HUD so that you don't get to see the answer. Hold on, I got to turn off chat too because that would kind of be counterproductive. Okay. Somebody wants to take a try at telling me what this equation is. Go ahead and type it in. You can use that format that we used up above that you see in the chat. And I'll give you a second. You just go from left to right, just like your eyes look, just like you read. And you put down how many you see of the big things, the cubes. You'll put an x cubed behind it. Then you'll see how many squares. Now that's good. Thanks, Rosalind. It's kind of fun having you all in one class. Talking out loud. So they're telling you the answer. You know what? It's okay if somebody just wants to tell us. How's the interest level? I know these guys aren't mathematics.
Yay!
Excellent. I would venture though that nobody, when they came into your class today, were thinking that at noon, near noon, they would be able to recognize a cubic equation and write down the equation. We'll do one more, and then we'll wrap it up.
Oops, I took out the negative.
Okay, there's one more for you. Take you through some of the other bases so you can look at it. So there we are in base 7. In base 6, you're going to see the same sequence. Look at that. Exact same shapes. Place shapes have meaning, an incredible amount of meaning.
Absolutely.
And did we get the answer? We can look at any one of these. Excellent, Malerica. Excellent. That is it. Does everybody see her answer? I go look at base 10. There you see the value. Now, let's show you one example. I'm going to give you back to Uta. She's going to show you a slide just to let you go. Whoops, where's it?
I'm back. Going back. Here we go.
Just wait for it to res.
Yeah, so what we found is when you're collecting data, and here we have a prototype of a little creature running across the field, and we measured it at 6 seconds. He was at 27 feet, at 7 seconds, at 31, and so on. You can see the data, the standard data chart over there on your left within the picture. But what we did was we took those seconds. Nobody click.
Clicked on.
Okay. We took that data and threw them into these base sheets, and you can see the meta pattern that it throws out. So in base 6, it ends up being 4 segs and 3 1s. It's a little far away to be able to see that here, but the same thing that we were seeing on the placemats that Cooper just showed. And it's the same pattern, 4 3, 4 3, 4 3, 4 3, which ends up being your 4x plus 3. And in this case, 4 times whatever seconds, so it would be 4s plus 3.
Got the word that they got to head out to lunch. So what I want to do is just wrap this up real quick. I'll take you back to us. Hi, guys. We can actually look at everybody. There's everybody standing. Okay. Thank you so much. I don't want to hold you guys from lunch. The sushi can't be eaten. So we know that you've got to go eat something real.
Can you go back to the presentation board?
Oh, did you have some? Okay, hold
Yeah.
on. We're going back one more thing. Please remain seated because I can't. Are you there? Pooja, you there?
So, yeah, I'm here. So just one more thing. If you're interested in helping us out, we are definitely looking for partners for research and housing learning stations and universities that are interested in working with us. So math-oriented people, send us around. We could use the networking.
Hey, just click on the two posters behind me. One's a picture of me. Boise State's hosting our site. The sushi bar is located at Boise State. So pick up a t-shirt and those cool Ray-Bans, and then click on the Dream Realization poster and get some information about us, and get a right hand, which is a really cool little thing. It's shown there and it actually works. So feel free to click, and I hope we didn't make you late for lunch. I'll just go to one of the security cameras here and we can watch ourselves. Go ahead and depart.